So the objective today is to understand unusual solutions to a system of equations. And then we're going to review graphing a system of equations. And we're going to get into minute detail because so much of what I saw today is missing what we had talked about before, and we didn't keep that straight. So we need to make sure that we keep this all straight. Understand unusual solutions to a system of equations and review graphing a system of equations. All right, so we do have three types of solutions in a system. The one that you guys practiced last night was there was one ordered pair that they had in common. So you would have parentheses, the x-coordinate, comma, the y-coordinate, done. Okay, and that was everything that I gave you for homework last night. That's what was on there. Okay. The second one, what we just did when we were doing graphing, was an infinitely many solutions. And by the way, there is no abbreviation for this. You cannot write IMS, Isaac Sowers Middle School, right? Okay. It's infinitely many solutions. And that came about when the two equations were identical. Now, we didn't notice them to be identical until we put them into slope-intercept form. So in order to compare the equations, we have to get them to be comparable, and that means they have to be written in a certain manner that you can compare apples to apples. So we want to look at slopes and we want to look at y-intercepts, and we can only do that if we put it in the slope-intercept form. The third one, Cameron, you're being obnoxious.
Sorry.
Sophia, you're a saint to put up with him. The third one, there was no solution. What did your graphs look like when there was no solution?
They were parallel.
They were parallel. So these are going to be parallel lines. And what was true about our equations when we had parallel lines? Yeah, we had the same slope. So again, the only way I could tell about the slopes is if they were written in slope-intercept form. So the only way that's really going to make sense to me to do anything is to get things into slope-intercept form. If I want to graph using a table, it's best if my points are in slope, or my equations are in slope-intercept form. If I want to graph via slope-intercept form, I have to have them in slope-intercept form. Okay? I know that's kind of hard to read at the bottom, so I'll repeat that. No solution. That means we had parallel lines. That means we had same slope once they were put into slope-intercept form. I can only identify slope once it's put into slope-intercept form. Okay? So those are our three options for a solution. We can get exactly one ordered pair because they cross exactly in one place. We can get infinitely many solutions if the two lines are exactly the same line. So that means same slope and same y-intercept. And then if we get no solution if they're parallel, which means they have the same slope but they have different y-intercepts. Okay? But again, the key ingredient is slope-intercept form. Now, I don't know, because nobody raised their hand, so I don't know if it's because you didn't want to raise your hand, but from what I gathered, you guys were using slope-intercept form to graph. and not a table. So the whole entire time, regardless of how the equations are given to you, you need to use slope-intercept form. Samantha?
Do you have tissues?
I think there's some at that top shelf. There's an extra box I just discovered. Okay, any questions on this? All right, so let's write down a couple, let's do a couple of these so you can understand. So we're going to have two equations. Direction is going to be find a solution to the system. And we're going to have these two equations. Y equals 2x plus 1. Y equals 2x plus 3. So we're going to go through the process of graphing these to make sure that you guys remember how to do that, because again tonight you have to graph. So slope on the first one is what? 2, which we're going to rewrite as a fraction. So we're going to give it a denominator of 1. And what's its y-intercept? 1. Okay, on the second equation,
2.
We have a slope of 2, which again we're going to rewrite as a fraction, 2 over 1. And what is its y-intercept? 3. Okay. What do you notice? That's the same for those two equations. The slope is the same. So if slopes are the same, are the y-intercepts the same in this one? No. So if the slope is the same but the y-intercepts are different, what do you think the lines are going to look like? Okay, so we think they're going to be parallel, so let's check it out. So I'm going to actually count 2 boxes by 1, because my boxes are really small compared to the boxes you have on your graph paper. Okay, so I want to go where, oops, I got to go up one more. That would be 4. I'm going to go for the blue one where the y-intercept is 1, and then I'm going to rise up 2, so this is rising up 2, and I'm going to run to the right 1. That takes me to the point 1, 3, and then I'm going to draw my line through those points. Okay, the purple one says I want you to start at 3. Oop, I'm going to have to go up a little bit more on the y-axis. I'm going to go up a little further. Oops, no, he's good. Bring him up. Okay. And from that purple point, I'm going to rise up 2 and to the right 1. And then I'm going to draw a line through those 2 points. And absolutely, what we discover from these two is that they are parallel lines. And there's going to be no solution. So our ultimate answer is no solution. Okay. Now, part of the standards that we're covering use this notion of inspection. Inspection is by inspecting your equations, you may recognize that your slopes are the same, but the y-intercepts are different, therefore your lines would be parallel. And that you know that if lines are parallel, they'll never intersect, so there would be no solution. So if you recognize and say the slopes are the same, but the y-intercepts are different, therefore there's no solution, that gets you out of having to graph it. Okay? So I'm going to write that piece down. Inspection says, upon looking at my equations, I noticed slopes were the same, but y-intercepts were different. Lines would be parallel. There is no solution. With Common Core, this explanation is just as good as graphing. Okay? But if you're not one to recognize things, then you can graph and find the answer. So you have two options how you can do this. If you, by inspection, notice that the slopes were the same, oops, that should say but. But the y-intercepts, oops, I skipped out a lot, didn't I? Were different, sorry. That's what happens when my brain is going. Therefore, the lines would be parallel, and there is no solution. So that is as good of work and understanding of the material as doing the graph. Okay? So if by inspection you notice, you can tell me, you write it out, give me your explanation why you know that there is no solution. Okay? Let's try a different one. Everybody good? All right, let's try another one. Let's say we were given this equation, or these equations. Y equals 2x plus 1, thankfully are already in slope-intercept form, and y minus 3 equals 2x minus 2. So the first one is already grabbed. They've already put it in slope-intercept form. Our job is just to write out the two key pieces of information. What's the slope of the first one? 2, which we're going to rewrite as a fraction, 2 over 1. And what's the y-intercept? 1. The second one isn't in slope-intercept form, so we're going to have to take care of that first. So to do that, we're going to keep y alone by adding 3 to both sides. And when I do that, I get y equals 2x plus 1. So what I get here is a slope of 2, which I'm going to write as 2 over 1, and a y-intercept of 1. Honestly, I don't think you should ever have to graph this, because what should you notice by inspection at this point? So by inspection means you're just observing both the slope and y-intercepts of the equations are the same. They are the same line. There is infinitely many solutions. Personally, why take the time to graph that? When you notice identical slopes, identical y-intercepts. Aaron? Okay. Now, I'm going to show you one more thing that's going to show up on the homework tonight that doesn't look like perhaps what you're used to. And instead of them giving us an equation, they're going to give us ordered pairs. So now we're going to have to remember how to write an equation with 2 ordered pairs. Last type of problem is going to be like this. One line passes through uh, 2, 3, and 0, 5. Oops, I did that. Okay. The second line passes through 1, 1, and 0, negative 1. What is the solution? So I'm going to separate my 2 points. These belong together. And these belong together. Okay, first off, what do you notice by inspection on those particular ordered pairs? It does reveal something. Justin? Pardon me? It tells you both of the y-intercepts. The ordered pair that starts with 0. What do we know about the y-intercepts of this particular problem? Are they the same or different? They're different. Okay, so what? First thing I know by inspection, it's not infinitely many solutions, right? Because they have different y-intercepts. How can I go to the next piece? What can I do?
Find slope.
Find slope. So let's do that. So the slope of this guy is going to be y minus y over x minus x. I get negative 2 over 2, which gives me, what's the slope? Negative 2 divided by 2? Negative 1. Okay, that's that slope. Let's check out this slope. 1 minus negative 1 over 1 minus 0. 2 negatives make a positive. I get 2 over 1, which gives me a slope of 2. Are those lines parallel? No, they are not parallel. So what does that tell me how many solutions I'm going to get to this particular problem? I'm going to get exactly 1. Here's why. I have 3 options. They cross once, they're the same line and have all the points in common, or they're parallel and have nothing in common. In order to be parallel, they have to have the same slope. These don't have the same slope. They don't have the y-intercept, so they're not the same line. Therefore, there has to be one solution. In order to get that one solution, I can graph it, and I would be graphing this equation. Y equals negative x plus 5, and I would be graphing this solution, y equals 2x minus 1. And then once I graphed it, I could figure out what the solution is. Okay? So to graph, do here, y, negative 2, 2, 3, 4, 5, 2, 4. And I'm going to go to where on purple side the y-intercept is 5. And I'm going to go down 1 into the right one. And then I'm going to graph that. And then on the other one, the blue one, it has a y-intercept of negative 1. Let me put that in there. Then I'm going to rise up 2 and to the right one for that slope. And if I was using a better system for my graphing, I would get the ordered pair as 2, 3 would be the solution. Now I can always check my solution by plugging it back into both equations to see if it makes it true. So is 3 equal to the negative of 2 plus 5? And I get 3 equals 3, so it works for that one. Over here, 3, does it equal 2 times 2 minus 1? So is 3 equal to 4 minus 1? And yes, it is. So that verifies that this is the correct answer. All right, good luck.